Alright class, so now we're going to take a look at dividing square roots of negative numbers. And there is actually two ways to do it this time. Last time we had one way that was right and one way that was wrong, but this time we'll actually work out both ways. So let's look at the first way. First way we would do it is just pull out the I here and get rid of that negative. Pull out an I here and get rid of that negative. So basically I'm rewriting this to be I root 75 over I root 3. Now what's really nice is that my i's cancel, because an I divided by an I is just like any other number. When you divide it, it goes away. So now this turns into the root of 75 over the root of 3. Now what we have to do, there's two things you have to do. First of all, it'd be nice to simplify the top, but you also need to rationalize the denominator. So I do that by taking the 75, doing my hockey stick. I can pull out a 5, and 75 divided by 5 is 15. And then I divide that by 5 again, and I get 3. So what that does is I get to pull out a 5 on top. So I get 5 root 3 over the root of 3. And I actually get away from actually having to multiply top and bottom by square root of 3, because I get to cancel them out right here. The answer is 5. So that's the first way. I would consider that the longer way of doing it, and here's the second way. The second way takes advantage of the rule that I showed a couple lessons ago, that the square root of a fraction is equal to the root of the top over the root of the bottom. Now this works both ways. If I'm given this, I can go that way. And that's actually what's given in this problem. I have the root of the top over the root of the bottom. I can rewrite this to be the root of the whole thing, negative 75 over negative 3. And that makes my whole life a lot easier, because I can just cancel out the negatives without having to pull out any i's. Because this is still valid, because it's not that they're two separate problems, it's actually one thing. And then I'm just left with the square root of 3 over 75 over 3, and I just reduce it to be the square root of 25, because 75 divided by 3 is 25, and so the answer is just 5. Same answer I had before, just another little bit quicker way of doing it. So now we're going to work on adding complex numbers. When I add complex numbers, it's just like adding any other like term that you've ever added in algebra. Notice they give you parentheses. Those are just to confuse you. Just get rid of those parentheses here, because they don't serve any purpose with a plus sign in the middle. So I can rewrite it to be 2 plus 3i plus 6 plus 4i. Now, all you have to do is find what your like terms are. The 2 and the 6 go together, and that gives you 8. The 3i and the 4i go together, and that gives you positive 7i. Okay? Now, when you write your answer, it's best to write 8 plus 7i rather than 7i plus 8. You don't want to do this. The reason why is because you always put your real part in front of the imaginary part. You can see that there is an imaginary part of my solution, and that's the 8, and the imaginary part of the solution has the I in it, because it's there, but it's not really there. The 8's real, the 7i is imaginary. So real comes before imaginary. So now we're going to do the same thing, but this one's subtraction. This time the parentheses are important. The first parentheses not so much, but the second parentheses is important, because you have to actually distribute the negative to the 3 and to the 2i. So what happens here is you get 6 plus 5i without the parentheses, because again you don't need them. And then it's going to turn into negative 3 minus 2i. And just like the last problem, all we have to do now is combine like terms. So the 6 minus the 3 gives me 3, and the 5i minus the 2i gives me 2i positive. So again, I write the real in front, the imaginary behind, and the 3 plus 2i is my solution. So now we're going to work on multiplying with complex numbers, where we actually have to take a complex number and distribute into a set of parentheses. And sometimes there will be other imaginary numbers inside there, so we've got to work back with that original slide I showed us and remember what our different I powers are equal to. So I'll just write them down really quick. I, we just write I, that's square root of negative 1. I squared is negative 1. I to the third is negative I, and I to the fourth is 1. Okay, so we'll just hold that off to the side. And then we've got 3 times 5i, which should be 15i squared. And then 3i times negative 2 should give me negative 6i. Now I can't leave my answer like that. What I need to do is simplify further. Anytime you have an I squared, I can't leave it like an I squared. I got to come over here and realize that I squared is actually negative 1. So when you see this, it's actually 15 times negative 1, which should just give you negative 15, and then I just have my minus 6i. So this is my simplified solution. Again, the real part is in front of the imaginary part. The negative 15 is in front of the negative 6i. So that's your final solution there. Now let's erase, and we'll take a look at this bottom problem. The bottom problem requires us to FOIL. So I do my first, I multiply my 3 times my 4. I'll write it up above to give myself space. I get 12. Then I multiply my outers. That should give me negative 9i. And then I should multiply my inners. And that should give me positive 20i. And then I should get my last, which would be negative 3i times 5i, and that's going to give me negative 15i squared. And so, first of all, before I even get simplifying yet, I should see that my I squared again is negative 1. So really this is negative 15 times negative 1. So I could reduce that to be positive 15. And then I have over here 12. So those are actually going to combine. Give me 27. And then I go ahead and take my negative 9 and my 20, and that should give me positive 11i. So my final answer is here, the 27 plus 11i. So again, the key to watch out for is that when you do your i's squared at this step, that you take and actually see the negative 15 is being times actually by a negative 1. That gives us the positive 15. That's usually where my students make the mistake, is they leave it as a negative 15, or they leave the I squared in their final solution, and that's why you might get it wrong in the lab.